Hello everyone and welcome to this video on 8086 microprocessor architecture. This is the classroom discussion video number 3 under the course of U8 in EC506 microprocessor and microcontroller. So in this video we will be discussing on the architecture of 8086, how the architecture is being developed and how the flow of instructions are, how the flow of data will be moving within the microprocessor and out of the microprocessor. And the outside world, how the data is moved into the microprocessor architecture, and once the execution or the performance processor has done the work, and how it is sent back to the outside world that is being shown in this video. Coming to the architecture, on the screen you can see the architecture, the complete architecture of 8086 microprocessor. This is the architecture of 8086 microprocessor. In this architecture, you would be having two main functional units. Number one is bus interface unit, the other one is execution unit. So this line which has been shown over here, this won't be there in your physical architecture. For our understanding of what are the different components comes under bus interface unit and what are the different units comes under execution unit. To bifurcate them, we are using this line. So the top part about this line are bus interface unit, which consists of instruction prefetch queue or instruction queue, which is a 6-byte instruction queue. There is an address summation unit which goes for adding up the address and making it in a physical address. To make a physical address and get the total address of an data where it's being stored, to facilitate that one, we are having some segment registers. 4 segment registers are there, and one instruction pointer register. These all registers are being the part of bus interface unit. So the main function of the bus interface unit is to collect the data from the memory and feed it to the execution unit. So once the data is fed to the execution unit, it will take the data and it will go for processing the data using of ALU. Once data is been processed, whether it is an arithmetic operation or logical operation or any other operation which has been carried out using of this 8086 microprocessor ALU, it will process that one. Then using of which internally it will make use of the general purpose registers and pointer registers, and again it will be sending back the data and it can be stored into the memory. So this is the process over there. So as just now I told you, bus 8086 microprocessor has two main units. The first one is bus interface unit and the second one is execution unit. Bus interface unit, it fetches the instructions, reads and writes the data and computes the 20-bit address. So how it computes the 20-bit address? Using of this summation. It will be forming the segment address plus the base address, and you will be getting the total 20-bit address bus. So we will be discussing about how to go for calculation of physical address in your classroom discussion number 7. So till that we'll go ahead with this one. So execution unit decodes, executes the instructions using of 16-bit ALU. I told you we are having an ALU which is a size of 16-bit. So ALU is nothing but arithmetic and logic unit which performs the arithmetic operations as well as logical operations. And when you come to the what are the things available in your bus interface unit and execution unit? Bus interface units consists of the following registers. Number one is instruction pointer register. Number two is code segment, data segment, extra segment, and stack segment. All these 4 are what segment registers which are there in the bus interface unit. Segment registers. And next one in the let's take one example of how the data is being fetched from memory. So what it does is that bus interface unit, it takes for example, it goes for you want to read one instruction which is there in the code segment. So it will check the code segment register and instruction pointer. So what it does is that code segment register into 10H plus the instruction pointer address, these two are combined to get a 20-bit address. 20-bit address, it will form it up, and now this is called as a physical address, which is goes to the directly to the code segment, and it takes the data from there. So if you want to read the data from data segment, again the same process will be there. So here there would be a direct a pointer register would be used to point out over there, or an effective address can be found by one or two registers, or one displacement can be given. Like that way, different addressing modes can be given. So that we'll be discussing in the class of addressing mode. So how that. So bus interface unit work is to collect the data and feed it to the execution. Now execution unit is what? Execution unit work is, as the name may suggest over here, executing the data or execution of data. Execution of data to be processed, there is two things it need to go for. One is first one is going for encoding the instructions, and then reading out the instructions and following. So that is nothing but the work of execution. To facilitate that one, we are having some 4 general purpose registers, 2 pointer registers, and 2 index registers. These are the registers. This is the total complete register organization, and here you can see these all the registers which are there in the execution bus interface in the top one. Below are available in execution, and we'll discuss about that one, how the flow of data would be there, and we'll be discussing on to this instruction prefetch. Before I start with instruction prefetch queue, what I will say is that how the data is moving into the 8086 microprocessor. So here I will take an 8086 microprocessor. 8086 microprocessor is been there with the two functional units, bus interface unit and execution unit. So from bus interface unit, what it does is that it will calculate the physical address, it will go to the memory and takes the data. Now this data has to be forwarded to the execution. So execution unit, you would be having an ALU. ALU would be processing the data. So when the ALU is processing the data, bus interface unit work is what to collect the data. So at that moment, the bus interface unit is free enough. What it does is that it will take the help of instruction prefetch queue, and well in advance it will collect the data and it keeps in the instruction prefetch queue. Now when execution unit wants to execute the data, it doesn't go and refer to the memory. I mean to say, it doesn't ask the bus interface unit to get me the data from the memory. It will directly check the queue. Whatever the data is there in the queue, it will take it up and it execute. It never goes to the memory. So bus interface unit work is what? To get the data and put it in the queue. Now what is then a queue? Queue is in a 6 bytes memory location, we can say. It can hold a 6 bytes of information. Why 6 bytes of information only? So when you decode, we know that we are writing an instructions in a language which you say it as assembly language, which is able to be understood by, which can be understood by the humans. When you go for a machines, it can understand only the operational codes. We say it as opcodes. So each instruction can be, each instruction is converted into the equivalent operational code which can be read by the microprocessor. The size of the operational code varies from 1 byte to a maximum of 6 bytes. That's the reason the instruction prefetch queue is made up of 6 bytes. Mean to say, at least one instruction can be held in the instruction prefetch. And it is not going for enough larger size. The reason is that if you go for larger size instruction prefetch queue, again it will be going for buffering. Now let's take an example. Here you can find in this picture you can find one big layer is there who is standing at the one a stand or on a bench like thing, and there is an assistant who is working at the bottom. Now he is mixing up the cement or we can say the mortar, and there are some bricks over here. And what he is doing is that he is laying up or putting up the bricks. And what this assistant work is that he used to mix. He will mix up this cement. He will take this brick and he will provide it to the bricklayer. So the bricklayer never goes down and picks up the bricks or picks up the cement. So if he goes down and if we take the material and if we put up the bricks, what the thing will happen is that it would be just like getting down and climbing up. Each time is wasting some amount of time, which is been added together. Added together. So these time, when you say if each time he is picking up one brick or two bricks, let's say, and there are some 100 bricks. So how many times he is to go get down? If you want to lay 100 bricks, you need to get down 50 times. So the time is been multiplied. Each time it takes at let's say 1 minute of time, 50 minutes of time it requires. Suppose a assistant is there, this 50 minutes of time would not be required if a assistant is being provided. The same thing happens in the microprocessor. Referring to the memory, it takes a larger time. So instead of referring to the memory, it directly goes to the instruction prefetch queue. So that is the same thing. Here also you can see one more example. There are some person which are at the bottom, and there are some persons who are putting up the bricks. Same thing happens if they go down and take the bricks and they put it up on order to take a lot of time. Instead of that one more assistant is there who is throwing up the bricks at the top. They will be putting up the bricks to take a less time. This is the use of instruction. So overall here, 8086 microprocessor is a 16-bit microprocessor, and it has two functional units, bus interface unit and execution unit. Bus interface unit is to fetch the data and feed it to the execution unit. And here at the last we can say that never gives directly to the execution unit, but it would be storing in the instruction prefetch queue. From the instruction prefetch queue, it would execution will unit will take the data. It will compile the data and it will be storing in the registers or into the memory. Then a new data is been again taken from the first the instruction page. Like that, the cycle would be there, which is being shown. Thank you for watching this video. I hope you have understood the architecture of 8086. So the same thing over here. The instruction number 1 is been getting executed. Instruction number 2, 3, 4. How the parallelly process would be there. Fetch, decode, and execute would be carried out. Shown over here. And at the last, this is the flag register of 8086. Again, in the register organization, we will discuss about the flag register of 8086. It is a 16-bit flag register. Out of these 16-bit flags, 9 are the active flags, which are shown over here. So out of the 9 flags, 6 are status flags and 3 are machine control flags. Thank you for watching this video. Next video would be on the memory segmentation of 8086. Sorry.